Hello guys, I'm Aljan H. Ferrer from BSECE 3C. This video is about CE Performance Task 4. Differential pulse called modulation. So what is differential pulse called modulation? Differential pulse called modulation is a technique of analog to digital signal conversion. This technique samples the analog signal and then quantizes the difference between sample value and its predicted value. Then encodes the signal to form a digital value. So redundant information in PCM. You can see here is an example of redundant value information in PCM. So the sampling frequency is selected to be higher than the Nyquist rate. The samples are encoded by using 3-bit 7 labels PCM. So you can see that 3-bit levels PCM. You can see that 3-bit 001, 010, and so on, and the bit levels from 1, 2, 3, 4, 5, 6, 7. The sample quantized to the nearest digital level as known by small sig in figures. The encoded binary value of sample is written in the top of the samples. You can see guys that every small circle is on the top. We can observe that the figure that samples taken from 40S and 5TS and 60S are encoded in the same value. So the 40S, 5TS, and 60S are encoded in the same value. The information can be carried by only one sample, but there are 3 samples carrying in the same information means that is redundant. We consider the example of samples taken by 90S and 10TS. So the 90S and 10TS. Here the 90S and 10TS. The difference between these samples only due to last bit and the first 2 bits are redundant, as they do not change. If this redundancy is reduced, then the overall bit rate will decrease. The numbers of bits required to transmit in one sample will be reduced. Then we go to the DPCM transmitter. So this is the example of the DPCM transmitter. So this is the sample unit, the input, sample input, the X and TS. From the X and TS, it will result to the prediction error, go to the quantizer. But before that, predicted signal X and TS will combine to the sample input, the X and TS, to form an prediction error, E and TS, and goes to the quantizer. So the prediction error is equals to E and TS equals X and TS and X prime and TS. Then the quantizer error or signal is output is equals to EQ and TS from is equals to EN and TS plus Q and TS. Then goes to the encoder, and from the encoder it goes to the DPCM output. DPCM receiver. So this is the example of DPCM in receiver. So this is the input BN and TS to the decoder, then goes to the EQ and TS, and from EQ and TS it goes to the comparator. Then before that, from the predictor, AX and TS also goes to the comparator. Then the LPF or the staircase approximate signal is equals from EQ in TS to X prime in TS. Then it equals to the signal. So this is the recovered examples from EQ in TS and X prime in TS to XQ in TS. So the EQ in TS of 1, then 0, 1 plus 1 is equal to 0, 0 and 1, 0 and 1 is equals to 1, 0 and 1, 1 plus 0 is equals to 1, 1 plus 1 is equals to 2, and 0 and 2 is equals to 2. So the recovered samples is equals to 1, 1, 1, 2, 2. The decoder first reconstructs quantized error from the incoming binary signal. The prediction filter output is quantized error signals are summed to the give quantized version of the original signal. Thus the signal of the receiver differs from the actual signal by the quantization error of Q and TS, which is introduced permanently to reconstruct signal. So what is the advantage of DPCM? The advantage of DPCM is 1. As the difference between x and ts and x prime and ts is being encoded and transmitted by DPCM technique, a small difference voltage is quantized to be encoded. Number 2. This will require less number of quantization levels and hence less number of bits to represent by them. Number 3. The signaling rate and bandwidth of DPCM system will be less than the PCM. Then the summary. The main purpose of DPCM was to reduce or eliminate the redundancy of transmission of the same encoded redundant values in successive way, which was not good in terms of data communication because it was prone to error. To decrease overall transmission of bit rate and number of bit level required to transmit per sample will be greatly reduced. DPCM uses less bandwidth than PCM, due to it requires less quantization values or levels which enable to use lesser number of bits to represent the quantized value. So that's all. Thank you.